Hello everyone and welcome back to this new LabVIEW webinar. Today I want to speak about something that is very actual, the raw material crisis for R&D and what it means for teams. We want to look at how AI-powered formulation can take a little bit of the pressure off experts and how it can support react better in future to such crises, the one we actually are currently living for the last 2 or 3 months. Just a couple of information before we start. This webinar is currently being recorded, which means the video is going to be available on demand on our website very soon. And you will receive a follow-up email anyway with all the links to look up the information. At the end of the session, we will have the possibility to answer questions. Use for that the Q&A button in your team screen, and I'll publish the questions and answer them right after. Before we start, for those who are new to a LabVIEW webinar, who is LabVIEW? LabVIEW is a company, part of the Edge Group, and our goal is to accelerate material innovation, to help our industry in Europe to keep shaping the world of tomorrow the way it has been doing for the last decades. The mission we have is really to redefine how material innovation is done here in Europe with an intelligent software platform that makes all the relevant material data or R&D data, if you prefer, usable, accessible, so that you can develop better products faster. We are enabling you to make data-driven and better informed decisions. But also we want to try, and it's really a big part of what we do, to open up the access to modern and future and the newest technologies, such as artificial intelligence, for any company of any size. We don't think technology should be only something that larger international multinational companies are allowed to use. We think every organization, doesn't matter the size, doesn't matter the industry, doesn't matter where it sits, should benefit from it. So everything we do is really from the industry for the industry. Before looking at how to respond, I think it's worth understanding what the raw material crisis actually demands from R&D today. In our opinion, 4 factors now show up in almost every development team. The first is price volatility. Swings of 20 to 50% within a few months are unfortunately no longer the exception. Cost calculations of a formulation, for example, can lose their validity before the product is even finished. So what you have calculated at project kickoff, for example, often no longer reflects reality by the end of development. The second risk is the supply risk. Geopolitical tensions, new tariffs with certain regions, maybe even regional shortages. What's available today won't necessarily be available tomorrow, and the availability of certain raw materials has become somehow a little bit harder to predict. Another risk is the shorter response times, because when a raw material becomes unavailable, there is no time anymore for classic trial and error development. The substitutions need to be operational within weeks and not within months. And all of this has to happen at consistent quality, because the specifications, the standards, but also the customer requirements aren't being relaxed because the market is harder. The tolerance and the acceptance for quality deviations hasn't grown at all, but the pressure to adapt formulation quickly has. And this is the double constraint R&D is facing today. React faster on the one side with raw materials that are more expensive or less reliably available, without compromising the quality of the results. When you clearly separate what you can control from what you can, the conversation around this raw material crisis becomes simpler. Here on the left, you can see the factors that always remain outside of R&D's reach. First, geopolitical context. There is no one in the development team that can influence international tensions, trade restrictions, or new tariffs. The next point is the supply chain disruptions. When an upstream supplier, for example, can no longer deliver, or when a logistics partner runs into trouble, that's not a problem you can solve in your R&D or in the lab. And finally, the raw material prices, they're set on global market. So there is no negotiation happening on R&D level. And these three factors define the pressure you're under in the R&D, but they're not the levers you can pull directly. What is actually in your hand is what you see here. The number of trials needed to reach a development target. That depends on how your R&D works with data, the use of historical data. Whether existing knowledge is fully leveraged or only fragmented depends on data structure, not on luck. And finally, substitution logic. The speed and precision with which you identify alternatives depends on your database and the tools you use. So today in this webinar, we're not going to focus on this left column because it's out of our control. We're going to focus on the right one. That's where concrete change is possible. When the raw material price goes up, the first reaction is usually the same. Look for more competitive suppliers, renegotiate with procurement, or even sometimes reduce the raw material share in the formulation. This feels totally logical because the raw material price shows up directly on your calculation and at the end of the invoice. It's visible. What doesn't show up directly on the invoice, but is just as real, is the cost per trial. And that cost is systematically underestimated. Let's look at what a single trial actually involves. First, the raw materials used, of course, at current market prices. Then you have the team's time for preparation, execution, and documentation, which is often the largest line item in this calculation. Add to that equipment use, consumables, then the opportunity costs, because when you work on some projects, the lab is not working on another one. And finally, the time to market, since every additional trial pushes the launch a little bit back. You then multiply this cost per trial by the number of trials per project, by the share of available repetitions, and by the number of projects you run each year. And here's your structural lever. Acting only on raw material prices means optimizing one single variable. Acting on the number of trials mean actually optimizing the entire equation here. And that's the difference between a few percent on savings and an actual something we would call structural gain. The question is, why are trials repeated so often? Most R&D teams still rely on Excel as their main tool. It worked for a long time, but today the limits are becoming very clear. Data volumes are growing, projects are getting more complex, and the pressure for speed keeps rising. 5 of the typical consequences we find at almost every customer. First, the scattered data. They're not connected. The sources are completely not linked with each other. Manual transfers of any type of data that leave gaps, no shared consistent data structure within the team. There is no cross-project access to historical data. And in the end, depending on the industry and the size of your team, you ended more to spend 45 minutes to maybe an hour per day just looking for information regarding projects. That's time that is not spent on R&D tasks. It's just waste of time. If you look at this, 45 minutes a day for a team of 10 people in the R&D means one full-time equivalent employee per year just looking for data. So at the end, it's just easier to rerun the trial, right? Maybe an example, how it looks like today in the current situation. You have a supplier who just announced it will stop delivering their key raw material from Q3 on. Our R&D manager remembers that a substitution for this exact material was tested somehow 2 years ago, but no one remembers who ran it. The trial results are not accessible right away because they're spread across several Excel files. Even the lab reports are in another folder because somehow the QC did use it. And after 2, 3, 4 hours of searching, the team just gives up and starts the substitution trials from scratch again. And that's not a discipline or a competence problem, right? It's a direct consequence of the tools that the teams are working with today. To address these challenges as a whole, adding just an isolated solution for data entry or for project management is not going to be enough. And that's why we take an integrated approach, which we call material intelligence. The software is called the material intelligence platform, and this platform connects three core elements: the data, the processes, and intelligence. Let me explain first the data. We're talking here at the heart of our software about a structured, easily searchable database from trials, processes, material data, measurement results, and that's our foundation. Without this data, there is no solid decision at the end possible, whether you are in the lab or in the R&D, if these are two separate entities. The second element on the right side here are the workflows. Project management, resource management, lab processes have to be represented digitally, from formulations and samples through the equipment, and even, why not, inventory. This creates somehow some type of a coherent workflow in which everyone is involved, who is involved works with the same information base. And finally, the third element, what we call AI or intelligence. I prefer the word intelligence. On top of this data foundation, you can have different AI applications used, whether for search or for predictions. The key point here is AI is not an isolated feature. It really builds on real data from the lab, from the R&D. And I want to make a point and insist on the fact that these three core elements aren't separate modules. They actually work together, right? One example, only when workflows are digitalized can the data really be complete. And only when the data is consistently available can AI be used meaningfully for example, predictions. And the intersection of these three dimensions forms our software, this kind of central operating system for R&D, for digital collaboration, and better decision, and ultimately, hopefully, better products. Because we don't want to dive too deep into our products, but for those who never heard about us, the four pillars of our platform, first of all, is the resource hub with raw material, formulations, test standards as sub-libraries. Then you have the project hub with experiment and project management, reporting, collaboration tools. The data hub, where you can search and analyze and even visualize your database. And at the end, something we call the co-engineer, which is the translation of the AI component we were just talking about. Two sides of it. One is the agentic system we have as a digital assistant, and the other side is the AI-guided design of experiment or experiment planning. So remember now the supplier call we mentioned earlier. This is exactly the kind of situation where the concrete value of structured data becomes visible. So three questions in this situation need an immediate answer. First, which formulations are affected? Second, what trials have we already run with raw material? And the third question would be, how do we secure this knowledge that we're gaining over the coming days or weeks with this whole process? I suggest we look at these three questions one by one and go a little bit into details. Let's start with the first question. Which formulations are affected when a raw material is no longer available? In your Excel-based environment, this is going to mean someone has to open files, check formulations, and manually trace the dependencies between elements. It can take hours, sometimes maybe days. In a structured data environment, it becomes a simple question put to the system. As you can see here, the first pillar of a platform is built on resources. You have all raw materials, formulations, process standards in structured and dedicated libraries while staying connected to each other. The formulation library brings together every recipe our team has created since LabVIEW was introduced in the company. And on the right, you can see our AI assistant. It works like a search engine for your own database, if you will. I'm asking a very simple question: which formulations contain a specific raw material, and it returns the complete list immediately within a couple of seconds. And that's basically, for me as an R&D engineer, the starting point of the real work. Instead of spending these 3 hours searching, I get a clear overview in seconds with, here's my risk parameter, here are the formulations I now need to work on. Speed is not the only added value here, because the real benefits to me is the accuracy of the search. No one in a team has to wonder anymore whether something was missed or not. The second question, what have we already tested with this raw material? For that, we need two different elements. This is no longer about identifying the affected formulations, just like we did before. It's about retrieving knowledge that already exists somewhere in the company's experimental history. Maybe a colleague, an experienced colleague, tested this raw material 2 years ago in a similar application. Maybe there are substitution trials that were stopped because the target property wasn't reached. This knowledge, it often doesn't exist within the company in a accessible way. It is available, but it's rarely accessible. That's why if you look here at the animation on the right, you can see our data hub, which is the data search menu. It works a little bit differently from the AI assistant shown before, even though the assistant could also be used here. The difference is that data search is available by default in the platform, while the AI assistant we've seen previously is an optional feature that you can take or not. In this case, I'm using very precise filters because I already know what I'm looking for. Every single field in the database can be used as a filter. For example, show me all the samples where a given property exceeds a defined threshold, or all the trials run with this raw material at a specific concentration. The result here is a very, very precise list, not somehow some kind of endless scroll through files. And this lets me answer not just, has this been tested before, but more importantly to me, with what result and under what conditions? And here is the real value in it. It lies in activating the knowledge that's already available in the company. The work done by my colleagues, by the teams over the past years, is finally usable for everyone without having to remember everything. The third question, how do we capitalize on what we are learning? Because what's about to happen in this raw material situation in the coming days and weeks is often more valuable than most of the trials run in the past years, right? Substitution trials done under pressure, they somehow reveal how raw material actually behaves better, where the limits are, because we test a little bit more under pressure, what works, what doesn't. This knowledge shouldn't disappear once the crisis is over. So Levy offers here two ways to capitalize on this knowledge. The first sits at the resource level. As you can see here, for every raw material, I can add complementary information, feedback from experience, my own observations, some kind of implementation recommendations, or maybe specific behavior that I noticed. This is exactly the type of knowledge that today often stays only in the head of my colleagues or an experienced team member, and when this person leaves the company, and the knowledge leaves the company with them. The second way sits at the trial level in basically your daily work. Every trial contains at least one sample, and for each sample, I can document not only the formulation, quantities, and the process parameters, as you see it here, but also descriptive information. What was observed, what behaved differently from expectations, which conditions were unusual. This is the moment when this full structured data becomes real organizational knowledge, right? Because the next crisis is going to come anyway. So the question is not whether you'll have to work on the pressure again, but whether you'll be able to reuse what you're learning today in this future situation. Before we wrap up, maybe a quick look at what comes next. What we've seen before or so far is the data foundation, structured raw materials, searchable experimental history, knowledge documented directly in the daily work. That's our base. The next step that builds on this foundation is AI-driven design of experiment. You can see here on this diagram a comparison from real optimization projects. The orange curve represents a classical experimental approach, try and error. The red X on the right corresponds to a traditional DOE method with approximately 150 trials. And the blue curve shows AI-driven experimental design. It reaches better results with less than half the trials required by the compared method. How does that work? The system doesn't just plan the next trials. After each result, it actively suggests the most promising experiments to run next. It's going to leverage basically historical and new data, material properties, and somehow continuously balances this exploration and exploitation of existing and new information. So in practice, this is going to mean, first of all, fewer trials, because the system suggests the next experiment in a targeted way after each experiment iteration. Better results, because you integrate all the historical data, but also the material properties. And at the end, faster decisions, because the next steps no longer rely on just my experience alone, but on real data. If I take the example of the current raw material context, this means substitution trials today carried out through a lot of experience and many iterations could tomorrow be completed with far less effort. The prerequisite, however, remains your structured data foundation that we saw earlier. Before we move to questions, I'd like to make a comment that ties back here to our webinar title. We call this webinar Raw Materials Crisis in R&D with the subtitle How AI-driven formulation is reducing pressure on teams, right? Yet, if you look at what we have presented today, you're probably going to notice that we actually spoke fairly little about artificial intelligence. And that's not by accident. Because today, the market's attention is mostly focused on AI-driven predictions. Software vendors, they showcase algorithms that can predict properties and plan trials and suggest substitutions. It's very appealing because it carries a strong promise of high efficiency. But in practice, this all only works if the foundations are in place. And those foundations, they follow a sequential logic and not some kind of parallel one. The first step is the database. Structured, connected, searchable data. Without it, everything else becomes impossible. That's the core of what we showed you today. One example, without having a proper data foundation, you will start a machine learning project for formulation predictions. The vendor is going to put a lot of effort. It's going to charge you a lot of money. The project is going to be very long, very difficult, and at the end, very costly. But no one will be able to tell you which data is missing or which data sources delivers a lower data quality. They're only going to try to make predictions based on something that is not complete. It would be like trying to bake a cake without using all the ingredients in the right quality. It doesn't make any sense. You may have success, but you probably won't. The second step is including some assisting AI, the way we have it with our assistant. It helps you search, analyze, and document existing knowledge very quickly and in a very, very complete and proper way. That's also what you saw with our assistant, by the way, but also the data search, which could be seen as this assisting AI. And then the third step is going to be predictive AI. Design of experiments, property prediction, that's the perspective we touched on a couple of minutes ago. Companies that skip the first step, they will never really reach the third one. Some vendors are currently trying to sell you some large chemical models or large language models adapted to chemistry or any other industries. It could work, but the probability that you can afford it is probably very low. And I think that's probably the most important lesson from the past years in this whole AI R&D projects. The companies using AI productively today first invested in their data foundation. And in this current raw materials crisis context, this means something simple. You can't wait for AI and machine learning to save you, but you can start today building the foundation on which tomorrow's AI will actually be able to work and help you. Thank you very much for your participation and for your attention. If you have any question, we still have a couple of minutes left. Don't hesitate to use the Q&A function, and I'll be happy to publish and answer them. I'll go on mute for a couple of seconds. If no question is added in the next 2 minutes, I will just end this webinar. Thank you very much again, and see you next time.